and then share screen. Probably let me start with white first. Okay, so yesterday we started discussing about Q. And the Q is FIFO data structure. Who still remember what a FIFO is? FIFO is first in and first out. Okay, so that's FIFO. And yesterday, we also learned the concept about circular array. And who remember what the operator we use for circular array? Who remembers? Do we really have a circular array? When we do coding, it's still array, is it? But for the circular array concept, what do? We use
mod.
Yeah, mod. Okay. We use the module operation, is it? And with arrays. Arrays capacity, is it? Or arrays length, is it? And then we don't need, we can avoid what? With general linear implementation of the Q, avoid shifting, is it? Avoid shifting, okay. So that's the advantage for circular array. And we discussed Q implementation with circular array, is it? And we for Q implemented with circular array. We also needed to care about Q empty condition. So when Q is empty, how can you know if a Q is empty? And generally speaking, when we discuss Q implemented array, we have 3 instance variables, is it? We have front index, back index, and we have that array, is it? With a certain capacity, is it? We have those 3 instance variables. And what is the condition for Q is empty? How can you identify if Q is empty? Is front equals to back, is it? That's the Q empty condition. And because it's array, so we also have Q is a full condition, is it? When Q is full in the circular array that we drew yesterday, when the Q is full, who still remember? When Q is full, just visually, what
M front equals M back plus 1.
Yeah, so there is only one empty slot, is it? There is only one empty slot in the circular array, is it? So if we write it, it's what? It's the back index, is it? Plus 1, advanced by 1. And the module the array's capacity, is it? Equals to front, is it? That's when that's the case, then your Q is full, is it? And when we discuss the Q implemented with circular array, do we always need to make sure back index is greater than front index. Is that a necessary condition? It's not. Is it? Back index, you remember when we draw that circle, is it can sometimes be also less than front index. Okay, so that's generally general review. And also regarding Q, what we discussed yesterday is add a new item. When we add a new item, where do we add? We add at beginning, at back, or in the middle, or anywhere for Q. When you add a new item, where do you add? Who remember? That's a basic information. Whenever we add a new item, whenever we remove an item, when we add a new item, where do we add? We add at back. Is it? You cannot add at front. Is it? You cannot add in the middle. You add at the back. Is it? It's we need to follow the line. Is it? Like a checkout lane. Is it? No one has privilege. Is it? In this case. Okay. Whenever we remove, where do we remove? We remove at front. Is it? Remove at front. And when we add a new item at back, that special operation, we give it a name called what? InQ. That InQ. And when we remove at front, we call it what? We call it DQ. Okay, so those are the two operations. Is it? Okay, so that's the two operations. And then let's see, for Q. Generally speaking, over here implemented with circular array. Okay, what is UML diagram? Okay, let's discuss this. Is it? Okay, previously we discussed, suppose over here we consider an integer Q. Is it? So we have the front index. It's an integer, is it? And we have the back index. It's an integer, is it? And we have the array. And it's integer, is it? And those are the three instance variables, is it, regarding the Q class, is it? And then what kind of operation we interested, is it? First is what? Constructors, is it? We can have multiple constructors, is it? And then we discussed the two most important operations is what? InQ. And the InQ is you're going to add an item to the Q. So should the parameter be an empty one, or should I put something for the parameter? So what do you think for InQ? It's similar as stacks push.
We need a parameter.
Yeah, very good. You need a parameter, is it? It's an integer type, is it? And the return type, generally speaking, it's void. Okay, that's InQ. And then DQ. DQ, do we need anything here? We don't need, is it? Just like a pop, is it? And it's void, is it? You just remove the top item. And generally speaking, we also very interested in the front item, is it? So the front, you're going to get the front item, is it? So both of this are set method, is it? And this is what? This is a get method. is it? The front. And generally speaking, you are also interested in if the Q is empty, is it? So this is a Boolean. This also get, is it? And you also interested in if Q is full, is it? And the return type should also be Boolean, is it? And plus some other operation, is it? We can add on more, is it? So this is going to be the construction of the Q class, is it? So generally speaking. And then next, so we understand of the concept, is it? So next, let's take a look how we write our version of Q, okay, implemented using array, okay, using array. Annotation. Let's do this. Okay, so over here we are going to define our class Q, is it? And here we implement clonable interface, and there is a new interface. This is new, called iterable. Okay, later on we are going to use it a lot regarding collection framework. Okay. Quite useful, okay. And over here we have the front and back index, is it? And we have our array, is it? Our array. And for this, we are going to use a circular array to implement it, is it? And the capacity is 6, okay, 6. Okay, so instance method, we already know, is it? And then we are going to start to discuss the constructor, is it? So the first constructor is a default one. Default constructor. Okay, remember, always remember, because in our second exam, some of you when write about constructor, so always remember this is in Java, okay? In Java, when you write a constructor, no return type. Constructor, there is no void or something, okay? Never have any return type. And the name be the same as class name. Keep this in mind, okay? It's not you name constructor as constructor. That's not correct, okay? Because in the second exam, we still have some students name constructor as constructor. That's not correct. Constructor, the name must be the same as your class name. Over here, our class name. Class name is Q. Is it? So exactly the same, okay? And for default constructor, the parameter list is empty, okay? Parameter list is empty. This is called default constructor, okay, remember here. And okay, for our Q, we initial both front and back index to 0, okay? And for our array, circular array, we call new int. And why do we need this? Why do we need this? Because what? Because array is a reference type. It's a reference type. If you want to use it to store something, you need to allocate memory. Is it? So you keep this and you always need to do new, okay, for the array. Okay, so this is default constructor, nothing new here. This is constructor with arguments. Is it explicit value constructor? Okay, and this what it try to do is, okay, I'm going to create my Q with specified capacity. That's what it's called. And for the index, front index, back index, same thing. I initialize both as 0, is it? And I create my array with this specified capacity, okay? That's this part. Okay, not a lot of new things. And then let's take a look in Q. Is it in Q is add an item at the back? Is it at the back? The very first thing you need to check is to make sure Q is not full. Is it? So check if Q is full. Is it? So how do we, okay, back plus 1 module, is it because this is what? Circular array. And here we just use arrays dot length. Depends on, because why we don't use the default capacity is here. It depends on when you call new array, is it? How many memory capacity you allocated, is it? So that's why here you use arrays dot length. Okay, use arrays dot length. And if it is full, I'm going to throw an exception, is it? Full Q exception. We will come back later to explain. Otherwise, I add, be careful, okay, add item first. And then you update back index. Back index. Okay, and why do I need to do the module array dot length? Can I just get rid of this? Can I just do m back plus plus? Why don't I do that instead of doing the module? Why do we do this module? It's because of what? Circular array. Is it? Yeah, circular array. Okay, let me see. Someone answered in the chat. Yeah, very good. Circular array. Thank you. It's because of the circular array. Is it? So keep this in mind. This is how circular array plays. Very, very useful. So that you don't need to worry. Is it? I just apply whatever I did before. Is it plus plus? But over here, so you can basically, with a circular array, basically almost all of the operations, you can do something like this to avoid index out of bound. If you do this module, it kind of can guarantee you that will work. Okay, almost all of the cases. Okay, so keep this in mind. So in Q. Okay, so that's our first quiz question today. First quiz question. Can you just write down in Q? In Q method, is it we update m back as, so you just copy this line of statement. How do you update back index? M back equals, you can write m back. Can you send your answer to the chat and module this array dot length? Okay, so that's our first quiz question. Can you all just send your question to the chat? Send your answer to the chat. This is our first quiz question. Okay. So you just update back. How do we update back? Okay, I just want you to remember this. Don't forget, okay, everybody please send your answer to the chat. Okay, that is in Q, is it? And the next, let's see DQ. DQ, the concept is similar as when we learn stack. Is it when we learn, you cannot really wipe out the contents from the array, is it? So over here, you just update front index. That's all we can do, is it? And when front and back index fall to the same slot, that's empty queue exception, is it? Otherwise, did you see, you just update front. So front +1, then module arrays length, is it? That's how DQ works, okay. And then next, let's see the front item. So front is to get the front item, is it? And if queue is empty, you have nothing to retrieve, is it? So that's why you throw the exception. Otherwise, you see, it's very simple. You just get the first item, is it? With the index, front index, okay. This one is also pretty simple. And then empty condition check. Very simple, is just check if front and back index be the same, is it? And then for our toString method override, is it? Okay, so here we use a string builder first, is it? Here is very interesting, okay? And we said, oh, start your loop start at front index, ends at back index. And here's the question, why don't I do less? Instead of less, I use not equal. The second question is, why don't I just do I++? Instead, I do I+1 module array dot length. Anyone can guess the idea here, the loop? Because so far, whatever the loop you learned, it's always, oh, integer I from 0 is I less than some size. Then I++. We're kind of used to this, is it? Why over here, the termination loop, termination condition, I didn't use less than, is it? And the loop variable increment, I didn't do I++. I do I+1. So let's see if someone answered. No. Oh, yeah, someone answered. Very good. Okay. Back can be less than front. Yeah, very good. Yeah, because over here, if you recall, we do circular array. Is it? We do circular array. And with circular array, your front sometimes it's greater than back. Is it? Let's see, we have some other chat. If you do I+, it would mess with the array since we are using circular. Yeah, very good, very good, okay. Yeah, so because front may be greater than back index. Is it? Here we discuss index, is it? So that's why you cannot use less than, is it? Because your starting value may be greater, is it? And also you do I++, then it can cause a problem out of index, is it? Yeah, very good. Okay, and let's see some other chat. Loop termination can be less than, yeah. Okay, very good, okay. Okay, so over here, this is very useful, okay? This is very useful. Keep this also in mind, okay? When you write a loop, why annotation, okay? When you write a loop with circular array, you can start anywhere, ending anywhere. And when you want to, over here, we don't call it increment your loop variable, is it? We can call it advance to the next slot. Is it? It's what you can use module operation. Okay, so keep this in mind, it's quite useful. Okay, so this is regarding the toString, okay, and then you just append that with a string builder, and then we call the toString as a convert to string, and then we can return the string, etc. And who still remember we learned that concept? Why over here I don't use a string? I use a string builder instead. Who still remember what's the advantage of the string builder over string? Over string. What's the benefits? Who still remember? That's why in Java we need a string builder. Who still remembers that concept? Let's see. Okay, string is, yeah, very good. String is immutable. String builder is mutable, is it? And then if you use a string, basically what? It's kind of, so this is your heap. Heap, is it? You have hello. Then you add a word, you have hello word. Then you have a hello word. CS265, is it? Each time you have a string takes its memory, is it? Will keep growing, is it? Keep growing, and all of this will be thrown, is it? Garbage collection, is it? So that's not efficient versus string builder. Versus string builder. So here is your heap, is it? You have hello. That's memory. And then you have word. Is it? It's added like this. Is it? It won't waste any of the memory already allocated in heap. Okay, so keep that in mind. That's why we use string builder, because you may have the scenario you have millions of words. Is it? Then in that case, definitely string builder is more efficient. Okay, then next, about clone, is it? Okay, for the clone over here, what I did is I first create a new queue, is it? And okay, front index, I just do the assignment. Assign front to this clone queues front and back, is it? And then I do individual element by element assignment, is it? And then I return this clone, is it? Q clone. Okay, so my question is, why do I need to do this part? Can I just call, you remember, because clone is from where? From object class. Is it? You can also just call super.clone. So the question will that, if you just call super.clone, will that fulfill the purpose in this case?
It's going to be a shallow copy.
Yes, very good. That's going to be a shallow copy. Why? Because you have array. Is it? Our Q class has reference type instance variable. Is it? With reference type instance variable, if you just call super.clone, you cannot get real deep copy. Is it? If you want to real deep copy, that specific reference type instance variable also need a clone. Needs clone. Is it? it needs to be a deep copy also. That's why over here I call new queue. Is it because when you call this new queue, you call the constructor. And within constructor, it create a new array. Is it? That array itself has its own memory location. Is it? That's why, okay, so that's regarding the clone method, so pay attention. This is, you remember in your exam too, is it? We have some similar question, is it? That's clone. Okay, and then the last part, this is going to be very useful, okay? Iterable, okay? And iterable is what? It is an interface. Interface, okay? And if you remember, we use that kind of loop for some variable, is it, in some array list, or some array. What kind of loop we call that? Who still remember using this colon?
For each.
Yeah, this is for each loop. And why you can use for each loop? That's because this iterable interface. Okay, iterable interface, okay. So this is the idea, okay. And iterable interface, it has a method called iterator. Okay, later I'm going to show the Java official document about iterable interface. It has a method called iterator, and you need to override that method, okay? And that iterator method returns what? Returns an iterator. And this iterator, again, is also an interface. Okay, so that's kind of complicated here, okay? So it's an interface also. Okay, then let's see. Let's take a look at our code to understand it better. Okay, so over here, because our method, is it, or not method, our Q class implements iterable interface. Iterable interface, so you need to override its method. There's that method, I said it has. So this iterator method is from iterable interface, and it returns an iterator. Okay, return. And over here, you don't need to write. I said, okay, I'm going to return new Q iterator. What that is? Okay, so let's see. Okay, then here I define a private Q iterator class. And this iterator class is outside because over here I have my public class Q. Is it? And this is a private class called Q iterator. It's within the Q class. What do we call this kind of class? Previously, we also learned. Who remember that? Who still remember? When we discuss anonymous class, what kind of class? Who still remember that keyword? And then we learned lambda expression. Is it? And before we learn anonymous, we learn some other special type of class. What's that keyword? Who still remember? Very important concept.
Nested.
Yeah, getting close.
Inner.
Nest. Yeah, inner. Is it? inner class, yeah. A nested class. And then we can also say it's nested class, but nested is more broad, okay? Over here, it's inner class, is it? So this is an inner class. Is it inner class? And this inner class, did you see it implements this specific interface, iterator interface. And this iterator interface has 3 methods. When each time when you implement this interface, your class implement into this you need to override the has_next method, the next method, and the other method is called remove. Okay, called the remove. Okay, that's regarding this class, inner class, it implement iterator. What is this class's instance variable? It's this index. This is its instance variable. Okay, variable. Okay, so over here I define the constructor. Okay, once again, remember, okay, constructor must have same name as class name. You cannot name constructor as constructor, okay? Keep this in mind, okay? Okay, so over here, what I did is, oh, this is iterator, is it? I'm going to associate my instance variable with who? With front index. Okay, so be careful here. Okay, I associate my instance variable with outer class's front index. That front index used to what? Identify queues front item, the location, is it position? Or I should put it more precise. Location, just we said memory, is it position? Is it? Okay. Okay, this makes sense, is it? And then what this method has next? Has next is what's its purpose is to check if there is another element after the current element. So iterator, okay, so you have a bunch of items, is it? So in our case, we have a queue 70, 80, 90, 100. 110, is it 120 something, is it? So what is iterator? Iterator, it's start at the first item, okay, and then you can advance it to the next item. So iterator can be used to loop through your queue, is it? So visit item by item of the queue. From where? Always from the first item, from front, is it? So that's why over here it said has next. That means, you see, this index, is it? It's changing. It is changing, is it? And it's point to the current item. Current item's position. Is it? In this case, it's index position. Is it? It's always going to move, advance. Is it? So if it already reached the last item, of course, You cannot advance anymore. That's why we need this specific method. Has next, is it?
Excuse me.
Yeah, please.
So for the has next, index is less than m back, right? That's our Boolean condition. But like as we were told before, like m back can be less than m front, you know?
Oh, yeah, you're right. You're right. Yeah, you're right. So over here, yeah, that's a good question. Okay, I'm going to double check my implementation. Okay, yeah, I may forget to consider the circular array situation. I will revisit this. Okay, so after class. Okay, very good, very good, very good thinking. Okay, so anyways, but the concept, we got it. Is it? The concept is you don't want it to go beyond the last item. Okay, so that's the second method. Oh, that's the first method regarding this iterator. You need to override. And then the next method, the second method you need to override is called next. Okay, so over here it's return the next item in the queue. Okay, and at the same time you also advance your position to the next slot. Is it? Okay, of course you need to first check if you already reached the end. Is it? If you haven't reached the end, you're going to return the current one. Is it? Then the same issue here. Okay, so I also needed to revisit because over here I just do plus plus. Okay, and anyway, but so over here you return the current item. Okay, so the next is you return your current one. After you return the current one, you advance your position index to next one. Okay, we advance the position index to the next one. Okay, so that's the second method you need to override. The last one is for remove. Okay, and over here we didn't implement this. Okay, later on when we discuss collection, we will revisit this. So over here we just say, okay, it's going to throw unsupported operation exception. Okay, so anyway, so iterator, but anyway, that iterator interface, whenever you implement, you need to override this three methods: has next, next, and remove. Okay, so that's a general rule. And this is regarding this inner class, is it? And with this inner class, okay, what this iterator method gives you is, okay, it's going to create this queue iterator. Is it? Because iterator anyway is an object here. Is it? It's going to point so that you can advance. Is it? So you are going to return it at the starting location. Is it? Starting location. You're going to return this object. Is it? Now we can explain the for each loop, because basically within that case, so in this case of a queue, is it? Why you can do this for each loop is internally it has a loop to check if it reach the end of the loop. As if it's not, so if you still has next, if this returns true, you can get next. Okay, so that's why that for each loop works. So basically, internally it calls this two method. Okay, has next and next, has next within a loop. Okay, that's how it works. So anyway, that method returns the iterator. Okay, returns the iterator. And then let's go back now to take a look at our application, the driver. Okay, then we will revisit the exception of this. So over here, I create the first queue. Is it? Then I check if queue is empty. Is it? And what next is okay, because initially it's empty. Is it? And what next I'm going to do is, okay, I'm going to see how many items I want to add to queue. Is it? Add to queue. And then what? Okay, I use the keyboard to enter some integer number. Is it? Okay, and then over here, I'm going to in-queue certain number of items. Is it? And you can get all of the contents of the queue called the toString. Is it? And you can also call to check if queue is empty. Is it? And you can get the first item called front. So nothing new here. Is it? And then we have the search method. We have the second search method regarding queue. Okay, regarding queue. And over here, we also do. So this is also just like you remember for stack, we also use a loop. Is it? For stack, this is also used quite often as you use a while loop. While loop, the queue is not empty, you do dequeue, is it? And you can also do queue.front. A lot of cases we do queue1.front. Is maybe you can do system print line, is it? Something like that, is it? And then you do dequeue, keep loop, keep doing something like this, is it? Yeah, that's what we used a lot for queue. And then you can check if queue is empty, is it? And over here is just try, because in this case, you already dequeue all of the items from the queue. So basically queue is already empty. If the queue is already empty, you try to get to the front item, you will get exception. Is it? That's why over here I have that try catch block. Is it? Catch what? If queue is empty, I'm going to catch empty queue exception. Is it? Okay, so that's regarding queue empty. Okay, same thing if you want to dequeue again, it will throw exception, empty queue exception. Okay, so here let's see our two search method. The first search method, I want to find some item within a queue. Is it? And here my goal is I don't want this queue be changed. No change to queue. And if you want to achieve this goal, you need to create a deep copy of this queue. That's why here I have the queue copy. Then I do everything. I do dequeue. Is it on queue copy? Is it on queue copy? Okay. And then you can return, is it, if you find the item or not, is it? So this is how you find an item. You remove every item and then you check if the first item is the item. As we use this a lot, okay? And also here, be careful, okay? Can I swap this two? I do, okay, queue copy dot from not equal queue. And not queue empty. Is that a good strategy to swap? No. Okay. That's not a good strategy because in this case, if queue is empty, it won't go to here. Is it? So this is a short circuit. Circuit. C-I-R-C-U-I-T. Short circuit. Is it? So in this case, this condition is you need to check first. So that's why you put this first. Okay. And then next, let's see. Here we call search 2, still on queue. Is it? And over here for this search 2, you see I use for each loop. Is it? Here I use for each loop. Why I can use this loop? Because I the queue implements that iterable interface. Otherwise, you cannot use, okay, if I remove that implements iterable, remove that iterator method, then if you want to write something like this, that won't work. You must have that iterable interface implemented, then you can do this. And also over here, another advantage for this case is you don't need to worry DQ, is it? Because of an iterable interface, when we override the has next and next, is it? We didn't know removing involved. So you don't need to create a copy on Q, is it? You can directly work on Q. That's the benefit of iterable interface. Okay, iterable interface kind of just like a get function, is it? You don't need to, there is no set, okay, versus you see. So that's why over here we have both version, is it? That's clear. Is that we have search. For this first search, I work on the queue using DQ and the front. Is it? Then in this case, you need to create a copy if you don't want the original queue be changed. Is it? But for the second version, I don't need to have that worry. Is it? Because I use the iterable interface. Is it? That interface won't change your queue. Is it? Is just do item by item visit, is it? That's all how over here this two method compares. Okay. Okay, so so that's all of the